Okay, this is number 11, 13 and 14 and 15 in the diagnostic test, last set. Okay, so these two equations are quadratic equations, and the first one we're going to solve by factoring. But I noticed that negative 1/2 sitting there, and I don't want to deal with that. So how do you deal with fractions in your equations? Well, you're going to multiply through by the least common denominator. Good news is there's only one denominator, it's 2. So I'm going to multiply by 2, but I see there's a negative as a lead coefficient. I don't want it to be negative, so I'm going to multiply through by negative 2. Now this is a trick that you can use anywhere if you don't want to do the fractions. You can multiply both sides of an equation by any number you want to, and the value of the equation will remain the same. So you get the answers will be the same. Okay, so that's going to be x squared, negative 2 times negative 2, positive 4x, and then negative 96 equals 0. Okay, so now let's factor this. So when we factor, we have to find out what multiplies to be negative 96 and adds to be 4. So of all the factors of 96, what adds to be 4? So we're looking for numbers that are 4 apart because the signs are different to multiply to be a negative. And when you add numbers of different signs, they essentially subtract their absolute value. So we're looking for numbers that are 4 apart. And the ones that come to mind are 12 and 8. They're 4 apart. And 12 times 8 is 96. So I need to be a positive 4. So it's going to be plus 12 and minus 8. So those are the factors. And now, if two factors multiply to be 0, each one could be 0. So I'm going to set x plus 12 equal to 0, or x minus 8 equals 0. Set each linear factor equal to 0, and then subtract 12, x equals negative 12, plus 8, x equals 8. And those are my solutions, negative 12 and 8. Okay, now the quadratic formula. The quadratic formula is this. There's a song to it. Actually, there's several songs to it now. So I'd recommend looking that up if you wanted to memorize it. But this is going to be able to solve any quadratic equation that you have, as long as a is not 0. That's the number in front of x squared. That's what we mean by a. But it will solve anything. It doesn't have to factor, but you can solve it. So the first thing we need to do is put it in standard form. We talked about that before. That means the powers have to be in descending order. X squared minus 8x, that's x to the first, plus 5 equals 0, and 0 has to be on the other side. So they're standard form. Okay, now I'm going to plug in the numbers into the formula. So a, which is in front of x squared, is a 1. That's 1x squared. The b, which is the number in front of x, is negative 8. The c, which is the constant, is 5. And that's going to look like this. X equals negative 8 plus or minus negative 8 squared minus 4 times 1 times 5 all over 2 times 1. First step is I evaluate the radicands. Let's just get a number into there. X equals 8. Just simplify that real quick. Which is 64. That's negative 8 squared. Minus 20. That's 44. I would just do that on a calculator. I just don't have it handy. Leave that radical sign over 2. Okay, next you're going to evaluate the whole radical. Now, if it's a perfect square, you're lucky. It becomes a whole number. This one's not a perfect square. So it just means you have to simplify the radical, and you can look back to a previous exercise where we went over how to simplify radicals. Okay, so now I need to take a perfect square factor out of 44. The only perfect square factor that goes into 44 is 4. So square root of 4 is square root of 11. Square root of 4 is 2. 2 radical 11. So I'm going to replace this with 2 radical 11 divided by 2. And finally, just divide each side by 2. This step is unnecessary. I just want to show you that I'm dividing each term by 2. And that leaves me 4 plus or minus 1 radical 11. Now this is 2 roots, and this is expressed in simplest radical form. 4 plus radical 11, 4 minus radical 11. And if it asks you to round to the nearest tenth or whatever, you would just put 4 plus radical 11 into the calculator and see what came out, and that would be the decimal. Oops. Okay, so now the last question. This is a right triangle. We need to solve for RT. Let's put an X there. So this is not really an algebra thing, but it is a question that comes up quite a lot. This is the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. And what it is, A and B are the legs of a right triangle, and C is the hypotenuse, which is the one that is the side that's across from the right angle. It's always C. Always got to be on that side. So the placement of this is very important. A and B, the other two, the x and the 60 in this case, are interchangeable. So, in this case, I'm going to have x squared plus 60 squared equals 65 squared. Okay, so now I'm going to just do some calculations and figure out what that is. So x squared, 60 times 60 is 3,600. 65 times 65 is 4,225. Now I'm going to subtract 3,600 from both sides. So we get x squared equals 625. And then I take the square root of both sides. And the square root of 625 is 25. So, that's the missing side. X equals 25. And remember, this is only good for right triangles. And only for sides. So if there is an angle involved in this, other than the right angle, like if there was like 34 degrees or whatever, and they only give you two sides, that is something completely different. So that's Pythagorean theorem, and that's it for the diagnostic test.